In today's video, we'll take a focused look at two key routing concepts. We'll start with routed point-to-point links and how these dedicated Layer 3 connections create simple, predictable paths between devices. Then we'll move into EIGRP named mode, the modern, more organized way to configure EIGRP for both IPv4 and IPv6. By the end, you'll see how these two elements work together to form a clean and reliable routing design. Let's jump into our first topic, routed point-to-point links and how they fit into a Cisco 3-tier network. In this architecture, with the core, distribution, and access layers, point-to-point links provide direct Layer 3 connections between the core and distribution switches. Each link uses a very small subnet, typically a /30 or /31, and carries only routed traffic. By keeping these links strictly Layer 3, we avoid VLANs, spanning tree, and larger broadcast domains. This results in predictable routing behavior, faster convergence, and cleaner overall design. Routing protocols form adjacencies directly across these links, allowing for efficient route exchange and quick recovery from failures. This structure forms the foundation of a stable and scalable Layer 3 backbone. We'll begin this phase of the lab by establishing the routed point-to-point links that connect our core and distribution switches in both Branch 1 and Branch 2. These links will serve as the dedicated Layer 3 paths between these layers, each using a /30 subnet and carrying only routed traffic. Setting these up first gives us the clean, predictable connectivity we need before introducing any routing protocols or higher-level configuration. Now that our point-to-point links are in place, we can start configuring EIGRP across our core and distribution layers. For this lab, we'll be deploying EIGRP in name mode, which is the modern and recommended configuration style. Name mode provides a structured layout and makes the configuration easier to maintain in larger environments. Before we configure it, let's briefly cover what EIGRP is from a technical standpoint. EIGRP is an advanced distance vector routing protocol that uses a combination of metrics, specifically bandwidth and delay, to evaluate routes. It forms neighbor adjacencies using multicast hellos, maintains a topology table of all learned routes, and installs the best paths into the routing table. EIGRP also supports features such as route summarization, stub routing, and unequal cost load balancing, which makes it flexible in enterprise designs. In this lab, we're focusing strictly on the configuration workflow. We'll create the EIGRP instance, define the IPv4 address family, and then activate EIGRP on the interfaces associated with our routed point-to-point links. Once those interfaces are enabled, the routers will automatically form neighbor adjacencies and begin exchanging routes.